Good day, viewers, and welcome to this special edition of the organic chemistry. And today we are looking at again classification of alkanols on the basis of number of alkyl group. The last time we looked at how we can differentiate alkanols from one classification to another. Now we are considering on the basis of alkyl group. Don't forget to always subscribe and share our video, and always drop your comment in the comment box. Tell us how you feel about the particular, and also if you have a question, also drop your question there in the comment box. Now let's proceed quickly in solving this question: how to classify alkanols on the based on number of alkyl group. Now, in classifying alkanol based on number of alkyl group, the first classification we have the primary alkanol. So how can you tell that an alkanol is a primary alkanol? Because under the number of alkyl group, alkanol are classified into primary. Then we have the secondary. We have the secondary alkanols. Then we have the tertiary alkanols. These are the three ways we classify alkanols under numbers of alkyl group. So how can you differentiate primary alkanol from a secondary alkanol and from a tertiary alkanol? Now don't forget, so we're going to pick the first one now, the primary alkanol. Now in the primary alkanol, always remember that the carbon carrying the hydroxy group is attached to one alkyl and two hydrogen atoms. The carbon carrying the hydroxy group is attached to one alkyl and two hydrogen atoms. And if you bring this, if you bring this into a structural form, we're going to have CH3, then CH2OH. Let's try and expand this for better understanding. We'll have CH3, we have CH, then we have C, then we have H, then we have H, then we have OH. And the name of this compound is simply ethanol. So ethanol is a very good example of a primary alkanol. Ethanol is a very good example of primary alkanol. Don't forget I said the carbon carrying the hydroxy group is attached to one alkyl and two hydrogen atoms. So ethanol is a very good example of what a primary alkanol. And let's look at the secondary alkanol. Now in classifying the secondary alkanol, you should also remember that the secondary alkanol, the carbon carrying the hydroxy group is attached to two alkyl and one hydrogen atom. The carbon carrying the hydroxy group is attached to two alkyl and one hydrogen atom. Now, if we are to expand this out or bring it into structural form, we are going to have a compound CH3. Then we have CH3. Then we have CHO, then bracket O. Then we have, and again, CH3. And this is the condensed form. If we have to bring this out, we're going to have a compound in this pattern. Which therefore means we have the OH here, then we have our H, then we have our H atom, the hydrogen atom there, then we have our hydrogen atom here, and here. And if you look at this structure, we have the carbon carrying the hydroxy group is attached to what? Two alkyl. There are two alkyl and what? One hydrogen. So it's fitting into the definition of a secondary alkanol. The name of this compound is simply 1, 2, 3. Simply 1, 2, 3. That is propan. Propan is the name of this compound, propan. Then 2-or, propan 2-or. The name of this compound is propan 2-or. Now the 2-or there is still that is the carbon atom, the second carbon atom that carries the hydroxy group. The second carbon atom carries the hydroxy group, so it's called propan 2-or. Okay, now this is a good example of a secondary alkanol. Let's look at the last one, which is the tertiary. In the tertiary alkanol, let's look at the last one, which is the tertiary alkanol. Now in the tertiary alkanol, you should also be able to remember that the carbon carrying the hydroxy group is attached to 3 alkyl. The carbon carrying the hydroxy group is attached to 3 alkyl and no hydrogen atom. It is attached to 3 alkyl and no hydrogen atom. Now, if you want to bring this in the structural form, we want to bring this tertiary alcohol in the structural form. We are going to have a compound in this pattern. We're going to have CH3 or 3, the OH. If we expand that compound, we'll have a compound like this. We have C, then we have the CH here, then we have the CH there, then we have the H here, we have the H there, then we have the O. So this is the carbon carrying the hydroxyl group, is attached to 3 hydrogen carbon, 3 alkyl and no hydrogen atom. 3 alkyl and no hydrogen atom. 3 alkyl and no hydrogen atom. Now, in having this kind of compound, now let's name this. This becomes 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so we are naming, or you can name from here 1, 2, 3. 1, 2, 3. So, but the point there is that at carbon 2, if you are naming from here 1, 2, 3, if you are naming from here, that means at carbon 2 we have an methyl group that is attached to carbon 2, and that same carbon 2 we have what? Our OH group. So that means that this name of this compound is 2-methyl propan 2-methyl propan 2-ol. 2-methyl propan 2-ol. Don't forget the carbon carrying the hydroxyl group is attached to 3 alkyl. That's how we differentiate it from the other alkyl family, from other number alkyl, alkanols. And also forget that if we are considering this, there are 2 propanol, the carbon at carbon 2 carry the hydroxyl group and also carry the methyl group. That's how we come to the end of classifying alkanols based on numbers of alkyl. Please do drop your notification and your answer and your question if you have any.